Hey everyone, today we're going to do a video on the interior and exterior angles formed by a circle. And so we're going to be on page 25 in your packet. So I'm going to go ahead and share my screen with you so you can see that. All right, so first of all, I want to kind of show you what it means to be interior. So interior, for what we're going to be looking at, is mostly going to be formed by chords, but those chords could actually turn into secants. It doesn't really matter if they extend beyond the circle or not, but what we're looking at is what are these angles that are formed. And so this is an angle that's formed. Let me change the color so it's a little bit darker. But this angle is formed, this angle is formed, and those are vertical angles, so obviously those would be congruent to each other. But you also have, this angle and this angle that's formed. And so those are vertical angles, so they'll be congruent to each other. So we're going to have different angles that are formed, but the key is they're on the interior of the circle. We're also going to have angles that are formed on the exterior of the circle. So we're looking at two secants, we're looking at a secant and a tangent, maybe two tangents. But the key is that the angle is on the exterior of the circle. So you'll see it's not inside the circle anywhere, it's on the exterior of the circle. So that's what we're going to be looking at in terms of interior versus exterior. All right, so here's one of our properties. For this property, it says, if two chords intersect inside of a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. And I don't know about you, but that is a lot of verbiage. Okay, first of all, I'm like, okay, I don't even know what that really just said. Okay, so I'm going to kind of put it in terms that's a little bit easier to understand. Okay, basically you have these two chords, right? They intersect each other inside of the circle and they're forming technically all four angles, but we're only asking you for this one little angle right here. So what happens is when these chords intersect each other, they have these intercepted arcs. So I've got this 30-degree arc right here, and then I have a 110-degree arc right here. Now, what you need to understand is that when that happens, it's almost forming kind of like I don't know, like an hourglass or something like that. So we have this arc right here, right? And we've got this little section right here, all right? And then we've got this little section right here, and everything lines up, all right? So as long as they line up, then you're finding that angle that's on the inside. Okay, so what you do is you add the two arcs together and you divide by 2. So in this case, we're saying 30 plus 110 divided by 2. So that's 140 divided by 2, which is, sorry about that, 140 divided by 2 is 70 degrees. So this little angle right here is 70 degrees, okay? So another way to think about it is, since you're meeting in the middle, think about what happens when you meet in the middle with two numbers. Like if you had two grades in the grade book, how would you get the middle of those two grades? Well, you'd add them together and divide by 2. So it's kind of like you're finding the average. All right, but I do want to caution you that everything does have to line up. Okay, so this 30-degree angle, or arc rather, lines up here, and it's corresponding with this angle right here, which lines up with this angle right here. If you had a picture where the same thing happened and you were dealing with this arc right here, this arc right here, but then I asked you for this angle measure, well, then you couldn't just add the arcs and divide by 2. If you added them and divided by 2, so I don't know, let's just make something up. So if this was 100 degrees and this was 80 degrees, just to keep it simple. All right, I'd add them together and divide by 2, and I would get 90 degrees, right? All right, well, this would be 90 degrees, okay, because that's the angle that would line up. That's 90 and that's 90. And unfortunately, I got 90, so a linear pair here would give me that x is also 90. Okay, but it's not 90 because 80 plus 100 divided by 2 is 90. This portion is 90, and then you can get a linear pair using these two angles right there. Okay, so you'll see some other examples here in a little bit, but I just wanted to make sure you knew that it does have to line up. All right, so the other property is in relationship to exterior angles. So this one says if a tangent and a secant um, or two tangents or two secants intersect on the exterior of the circle, then the measure that's of the angle that's formed is one half, not the one half of the sum, but one half of the difference, all right, of the measures of the intercepted arcs. And so when you are subtracting the two arcs, it's easier to do the big arc minus the little arc, and you are going to divide by 2, and that's what's going to give you that exterior angle. So when they're on the inside, think about inside, you're meeting in the middle. So you take the average, you add them and divide by 2. But here they're on the outside. And so if you think about just outsiders in general, if there's somebody outside of your like group of friends, maybe they're outsiders because they're different than everybody else. I don't know. I'm just trying to come up with something to help you remember it. But if it's outside, you take the difference. You subtract and divide by 2. So for this example here, again, things have to line up, okay? So if I look at my arcs, then I have this arc right here that's really fat. Hold on. All right, I have this arc right here, and then I have this arc right here. All right, now together they don't form the full 360 because there's other pieces to the circle, right? But big arc minus the little arc divided by 2 will give me this exterior angle. So I'm going to say 171 minus 85 divided by 2. So I'm taking the difference. So because I don't want to make a silly mistake, I'm using my calculator, but I get 86 divided by 2, which is 43 degrees. All right, so this angle right here is 43 degrees. Now, keep in mind that when you are finding these measures, it should make sense. The answers that you get should align with the type of angle that it is. So, for example, if I would have done this math and I messed up, so like if I would have done 171 plus 85 divided by 2, if I would have done it like with the other property, I would have gotten 128 degrees. Well, this is definitely an acute angle, so 128 wouldn't have made sense. So I would have known that I had made a mistake. All right, so kind of use that in your favor. All right, so just a couple more examples. So this example here, you'll notice that we're looking at this arc, right? Okay, and see, I'm highlighting because I want you to see how things do and don't line up, okay? All right, so those two arcs that are formed by those two chords, they do not line up with the angle that I'm trying to find, but that's okay. What I'm going to have to do is I'm going to have to find the angle that does line up with them first, and then I'll be able to use the linear pairs to help me find the other one. So I would say, because I'm trying to meet in the middle, I'm going to add and divide by 2. So that's 164 divided by 2, which is 82 degrees. Now remember, my answer is not 82 degrees. The angle that's formed here is 82 degrees. And so is this other one right here. It's just kind of small, so I can't really write it in there. But if that's 82 degrees, now I know that I have a linear pair. All right, so this forms a linear pair. And remember, linear pairs, they are on a line and they form 180 degrees. So I can just say 180 minus 82, and I get this other angle, which would be 98 degrees. All right, and so that's my final answer. All right, another example, and these are on page 25 in your packet, just so you know. I'm trying to do the ones that are a little bit different just to make sure. All right, so if we look at number 7 on page 25, then we're looking at an exterior angle, right? But this time they give us the exterior angle. So the rule is still the same. The exterior angle is equal to the big arc minus the little arc divided by 2. So I'm just kind of abbreviating that. So I'm just going to kind of fill in what I have. Well, my exterior angle is 72. My big arc is 200 minus the little arc. Well, we don't know it, so we're just going to call it x. and then we're dividing by 2. All right, so I'm filling into my formula. So now I'm going to multiply both sides by 2 because I need to get rid of this denominator. So that would be 144 equals 200 minus x. I'm going to subtract 200 from both sides. So I get negative 56 equals negative x. And because we need x to be positive, we can divide by negative 1, and x would be positive 56. All right, so what we just figured out is that this arc is 56 degrees. Just this little piece right here. All right, that arc is 56 degrees. And what you need to think about is think about a circle. A full circle is 360, right? And then half of a circle is 180. So think about whether or not 56 makes sense. So I'm just going to kind of use lines to kind of help show you this. All right, but if I knew that this was half of a circle, right? That's half of a circle. I'm kind of piggybacking off of like where this arc might start. Okay, well, that's half a circle. So I know from here to here, all that's 180. Well, half of that is 90. So I'm like 90, 90, the other 180, you know. So does it make sense? This is definitely less than 90. Does it make sense that 56 could be the answer? You know, half of 90 is 45. Well, that's more than 45, but less than 90. So that's just another way for you to kind of think about it. All right, last example here. We have an exterior angle again. So we're looking for the exterior angle, which means we're going to take the big arc minus the little arc, and we're going to divide by 2. So the exterior angle is x. All right, but this time I don't know my arcs. Okay, so what we have to do is think about, well, what do they give us in the picture? Well, they give us an inscribed angle. So we can find the measure of the arc because we've already learned a property that goes along with inscribed angles. And that's that if we know an inscribed angle, then the intercepted arc is going to be twice that size. So that would be 128 degrees. All right, this arc right here is 128 degrees. Well, now that I know that arc, I can find the other arc. All right, because I know that a full circle is 360 degrees. So I can find this arc right here by subtracting the 128. So 360 minus the 128 gives me 232 degrees. So 232 degrees. Right, so now I know my two arcs. So I know my big arc is 232. My little arc is 128, and I'm going to divide by 2 because I'm finding the exterior angle. So 232 minus 128 is 104. Divided by 2 is 52 degrees. And then look at the size of this angle. I mean, does that make sense that it would be 52 degrees? Yes. All right, so what we have just done is we've looked at some of the properties for interior and exterior angles of a circle. And so now you can finish the practice problems on page 25. Have a good day.